In this video, we're going to look at topic 84, example 5, graph translations of the reciprocal function. So they're telling us to graph g of x equals 1 over x minus 3 plus 2. What are the equations of the asymptotes? What are the domain and range? So we are given f of x equals 1 over x. This is our parent function. And this is what we did in the last video. So maybe you remember 1 over x, we had the point 1, 1, 2, 1/2. So we have points that look like this here as well. We had an asymptote here as the x-axis and the y-axis. So those are vertical and horizontal. And if we connect our dots, our graph looks something like this. Okay, so if that's not familiar to you, just review the last video, but that is our parent function. The f of x equals 1 over x. So what we're looking for is translations of this parent function. Take a look at the statement below. It says the function q of x equals 1 over x minus h plus k is a transformation of the parent function f that shifts the graph of f horizontally, so horizontally by h units, and then the graph of f vertically by k units. Well, the nice thing is that we're familiar with h and k. They do the same thing that they've done before. So we were looking at problems maybe like this, but this time they're going to be written in reciprocal function form. But the rules for h and k remain the same. H controls left and right, k controls up and down. So if I look at my function here, the h value of x minus 3, so h is equal to 3, which tells me that there is a shift right 3 units. And then the k value is equal to 2, which we know means there's a shift up 2 units. So let's do some highlighting there so we can keep this in perspective. So shift right and shift up. So when you're shifting these, what I would recommend is that you shift the asymptotes first and then kind of fill in your points afterwards. It'll give you the boundaries before you start plotting points. Sometimes if we try to draw the graph without the asymptotes, it's just going to be a little less accurate. Obviously we're drawing by hand, so it's not going to be perfect, but at least it'll give us an idea. All right. They're also asking us to come up with the, let's see, we need the domain. So we need the vertical asymptote, the horizontal asymptote, the domain, and the range. Okay. So the vertical asymptote, that's the one going up and down, right? So we had x equals 0. We're shifting that vertical asymptote 3 units to the right. So instead of being x equals 0, this vertical asymptote is going to go through x equals 3. All right, so we'll draw our red line here. So the vertical asymptote is going to be x is equal to 3. All right, and that's what we have. That dotted line should be able to see that there. So that was a shift right 3 units. The horizontal asymptote, so that's where it was the x-axis. We're going to shift that up 2 units. So instead of being at x equals 0, y equals 0, we're going to shift that up to y equals 2. Now what you might notice is that your x value is the same as your h value, right? That was a shift right 3 units, so x equals 3. And the y value is your k value, which was a vertical shift up 2 units. So x is h and k is y. The two asymptotes are here if you can't see them as clearly. But remember, they're not part of the graph, so we're just going to use some dotted lines there. Now, in terms of domain and range, the domain, we want to know what values x is allowed to be or is not allowed to be. Well, my denominator is x minus 3, I cannot have a 0 in the denominator. So if x is 3, I get 3 minus 3, which gives me 0. So for the domain, x cannot be equal to 3. And that's a very plain way of saying the domain. You generally would be more specific with this, and we'll get into some interval notation and other ways of writing it. But just for now, let's say x cannot be equal to 3. Our range. So a range you can base off of the horizontal asymptote. So since y is equal to 2 for the horizontal asymptote, in the actual function, y cannot be equal to 2. So again, these tie in together, and the domain ties in with your h value and your vertical asymptote. Notice that your hk, so hk is 3, 2, and notice that your asymptotes cross at that point 3, 2. Okay, so keep that in mind. That sometimes will be pretty helpful to make sure that things check out. Okay, now plotting the actual points. Plotting the points is probably best to use the calculator. So you want to go to y equals. I'm actually going to plot the original as well. So I'm going to do 1 divided by x. And then I'm going to plot as y2 my g of x. So I'm going to do 1 divided by. Make sure to put the x minus 3, your denominator, put that in parentheses. And then we're going to add 2. And if I hit graph, notice that blue one was the original, that's our parent function. And our red function, the g of x, did shift to the right 3 places, and it does shift up. So it's good that this is matching up the way it's supposed to. Okay. So we'll just check that, make sure that's good. That'll give you a visual representation of it. Now, just to show that, I'm going to go back to y equals. I'm going to clear these out. And I just want to plug just one of these in. It's not letting me go. There we go. So I'm just going to plug in the one that we're looking for in this case. So x minus 3. And then we're going to add 2 to that. So make sure you've typed it in correctly. We don't want to make a mistake there. All right, and then I'm going to go to the table of values, so second table, and that's going to give me some points to plot. Notice, and this is important, notice at 3, where x equals 3, there's an error. That means it's undefined, which we said in our domain, x cannot be 3. So the fact that that matches up is good for us. That means we probably did something correct. Hopefully we did all of this correct, but we definitely know that that's at least correct. So I'm going to find some coordinate points that work quite nicely for me. One of the ones I see is 2, 1. So I'm going to plot the point 2, 1. Another one I see is 1, 1.5. I can work with that. So 1, 1.5. 4, 3. So that one's an easy point to plot. And 5, 2.5. Now I don't have a whole lot of other points that are all that user-friendly. However, I do know what this graph is supposed to be shaped like. So what I'm going to do is I'm just going to connect these dots, and I'm going to shape the graph on my own. Oops, that's terrible. So let's just fix that there, and that will go something like that. All right, and we now have our graph. Notice that the graph did shift to the right 3 spots. It did shift up 2 spots, or units rather than spots. You have your vertical asymptotes. Those will affect your domain and range. And that's kind of it. I think that covers everything. Remember that your h and k values, you should be pretty familiar with what those shifts are, right, left, or up and down. And then those will affect the asymptotes. Use the asymptotes to create some boundaries to help you graph your points. You will need to be familiar with the shape of the graph because it's not always going to be possible to get a lot of helpful points from your graphing calculators. You would have to change your x values, you'd have to change the table set, which for now we don't really want to do that. So just be familiar with the shape of it, and as long as you have 2 or 3 points, if you are familiar with how a reciprocal function looks, you shouldn't have too much trouble with that. Okay, that's it. That wraps up this lesson, and hopefully you have a pretty good understanding of reciprocal functions.